So we are trying to solve this 24. So here fyy is 0 between minus infinity to minus 1, and 3y plus, y plus 1 by 10 between minus 1 and 0, and 1 between 0 to infinity. So what does this mean? This just means 3y by 10 plus 3 by 10. 3y by 10 plus 3 by 10 if you want to write it in this format. So the slope here is 3 by 10. The intercept is also 3 by 10, and that intercept is going to occur at the place when y is equal to 0. So at y equal to 0 you will have the really speaking, at y equal to minus 1 you will have the intercept. You will have the intercept at y equal to minus 1. You need to plot between minus 1 less than or equal to y less than or equal to 0 this value. So at minus 1, what is the value for this? It will be 0. At 0, it will be y equal to 0, it will be 3 by 10. So 3 by 10 will be the value of the what you call intercept. With the line over here, you can just try to write it over here. So all these you can just try to plot, right? And you will get a difference between this and this a little. Only that try to understand that this is between 0 and 3, whereas this is between minus 1 and 0. This is between 0 and 3, and this is minus 1 and 0. Okay, this is minus 1 and 0. So you need to differentiate between this and this over here. So plotting should be proper. And after 0, between 0 to infinity, it will be just equal to 1. Between 0 to infinity, it will be just equal to 1. Okay, you can plot it properly for this. Similarly, you can repeat the exercise for this. Between 0 to 2, it is 4z by 10. Between minus infinity to 0, it is 0. Between 2 to infinity, it is just equal to 1. So there won't be any intercept in this case. There won't be any discontinuity here. Whereas here there will be discontinuity. Here also there will be discontinuity. That is the point to be remembered. So there won't be any discontinuity in this case. So no del function in the PDF, the probability density function. In both these cases, you will get a del function in the PDF. Okay? But here the del function might, the del function here might just correspond to at 0, that is del x. This will be del of y, most probably y plus 1, because you have at minus 1 to 0. Okay, that's the difference which we need to make out. Okay, you can try to plot this. Then we will go for the next topic. So next we will go for the mixed random variable example. This is a mixed random variable example which is there on the what you call 26. 26 is mixed random variable example. Fxx equal to c del x minus 1 plus 0.13, 0 less than x less than 4, and 0 otherwise. Okay. So now if you want to plot this, earlier we were given the CDF and asked to find the value of the PDF. Now we are given the value of the expression for the PDF, and we are asked to find the value of C. Also, we are asked to find the CDF. Okay, both these. So how do we do this? Let us see in the example. So this is what we have here. I am trying to plot this over here. Now, this first I will plot this 0.13. It's a constant value between 0 to 4. 0.13. So constant value here. Right? Now, once it is over, so above 4 it is equal to 0. So that's why above 4 it is equal to 0 here. Right? Above 4 it is equal to 0. Then you have C del x minus 1. That is x minus 1 equal to 0. X minus 1 equal to 0 means at x equal to 1. When you say x minus 1 equal to 0, then that just corresponds to x equal to 1. At x equal to 1, the magnitude of the impulse will be c, and that is what we have here. Magnitude of the impulse is c. So this will be the plot of the PDF. PDF. Given the PDF expression, we can write the PDF like this, PDF plot like this. Given the plot, we can write the expression like this. So that we should be able to understand, right? Okay. So having written this, now we need to find first c. So integral of this function from minus infinity to 0, okay, will be dx, should be equal to 1. But this exists here only between 0 to 4. That's why I have written 0 to 4. But otherwise it is minus infinity to infinity in the general case. In this particular case, it is 0 to 4. So 0 to 4, you have this. So what do we have? It is a constant value, 0.13, between 0 to 4. That is one issue. And the second issue is the, the del itself. The del itself. The, what you call the del itself over there. So that is this value, C of del minus 1, right? So that value will just give us the value C. You can write C over here straight away, right? C into 1. So now if you integrate what you call integrate this, you get 0.13x with limits, this is just a constant. So 0.13x, 0 to 4, and plus C equal to 1, and that is 0.13 into 4 minus 0. This will give 0.52, therefore C will give us 0.48. So having found this, next, what do? We need to write the expression for the fxx. How do we write that? We know that it is 0.13 between 0 and 4. Between 0 and 4, it is 0.13. So for that, we'll try to write over here as 0.13x, okay, plus 0.48 ut minus 1. Okay, this is 0.13x. This is 0.48 ut minus 1. In place of del, we need to write the what you call u. In place of del, we need to write u. So you can try to write in this way only, or you can try to write 0.48 ut minus 1 plus 0.13x. 0.13x is between 0 to 4. Again, this value is between 0 to 4. Okay, it might not have been written properly. This is the exact expression. This might not be right. Okay, but this is right. 0.13x between 0 to x to 0 less than x less than 1. 0.13x between 1 and 4, as well as, you should try to write 0.48. This is the discontinuity which will occur. So we can have the plot for this. So between 0 and 1, the slope is 0.13. At 1, x equal to 1, you have the discontinuity which is of the 0.48 value C, right? Then after the discontinuity, you will have again the same slope 0.13, right? 0.13 after the, same, the value 0.48. So naturally, if this is 0.13, this quantity will also be 0.13. So this is 0.13. This will be 0.48 plus 0.13. That will give us might be 0.61, right? 0.61. The slope here is again 0.13 for 3 units. From 4 to 1, 3 units. 0.13 into 3 will be 0.39. So here it will be 0.61 plus 0.39 will give us 1. So it is exactly satisfied. So after this, it will be just a constant. It will remain constant. Okay, it will remain constant. So there might be a mistake. No, you should not write like this, really speaking, but this is the right one. If you want to write like this, here you need to again multiply it by u of t minus what we call 4 minus u of t minus 1. U of t minus 4, u of x. I think the t is also wrong. It is x I should write. u of t minus x minus 4 minus of u of x minus 1 should be multiplied to this value. Otherwise, this is perfectly all right. Okay, plot is also perfectly all right. Now, let us take another example which we might have written there. Okay, so this we have tried to solve. Now we will try to solve this. The PDF of the random variable is fyy equal to c del y minus 3, right? C del y minus 3 plus 0.12 between 0 to 5 and 0 otherwise. Okay, between 0 to 5. Okay, so now we can go for solving this example. Fyy equal to c del y minus 3 plus 0.12. We can try to plot this first. So between 0 to 5, it is 0.12. And then you have the impulse at y equal to 3. Between 0 to 5 of y, you have 0.12. And at del equal to, at y equal to 3, you have the impulse, which is magnitude is c. Okay, figure is just similar to whatever we might have written here. Figure is similar to whatever we have written here, right? But only that it is between 0 to 5.12, and this c is not occurring at 1, but rather occurring at 3. Somewhere at 3 it will be occurring, and you need to find that value. So again, you need to write the same thing. 0.12, 0 to 5 it will be. Now this will become 0 to 5 in that particular numerical, and 0 to 5 will be 0.12 dx 0 to 5 plus c. So 0.12 dx 0 to 5 will give us the value. If you try to solve, you will get 0.12 into 5, that will be 0.60. So that will give c as 1 minus 0.60, that will be giving us 0.4. 0.4 will be the value of c. So once having find the value of c, please remember that it corresponds to the discontinuity value over here. So again, if you want to plot the value of f, then what will happen? Where c is occurring at y equal to 3. If you remember, if you just see this expression, c is occurring at y equal to 3. So now, if you want to write the CDF, then you will have capital F of YY, and this will become CU y minus 3. Del will become U. Del will become U. Then this will become 0.12 Y. 0.12 Y between 0 to Y less than 5 and 0 otherwise. Okay, 0.12 y between 0 to 5, 0 otherwise. That's all. So capital FYY, if you want to write, it will be CU y minus 3 plus 0.12 y, 0 less than y less than x, and 0 otherwise. So if you want to again, try to plot that, then what will happen? It will have a slope again from 0 to 3, which is of the value 0.12, then a discontinuity of 0.4, then again the slope will be 0.12 till 5. After that it will remain constant. Okay, after that it will remain constant. So almost same figure as we have here, almost same figure as we have here, only that the slope will be 0.12 till 3, discontinuity of 0.4, then slope of 0.12 till 5. Okay, so it will be at till 3 means 0.12 into 3 will give me the value 0.36 here. 0.36 plus the 0.4 will give me the value here as 0.36 plus 0.4 will give 0.76. 0.76, where 2 units from 3 to 5. Slope is again 0.12, that will give 0.24. 0.24 plus 0.76 will give me the value 1. So that is how we can try to write the expression as well as the plot. Okay. Similarly, you try to do for the third one also, right? And if you don't get, you please tell me. I'll just stop.